Hey everybody, this is Larry. This is day 29th of the General Leetcode Daily Challenge. Almost to the end of the month. Hope you're doing alright. Stay good, stay healthy. Wait, what? No, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I don't know. Largest rectangle in a histogram. Okay, it's a hard problem and you try to figure it out. Okay, I mean, so I would say that for this problem, oh yeah, I guess sometimes people are asking me for daily updates. I don't always have an update, and I don't really have much of an update other than New York is getting hammered with like 12 inches of snow today. So maybe I'll be indoors for a little bit. That's all I have. But yeah, for this problem, I'm not gonna lie, I have some familiarity with it, but I don't memorize it, right? Because I don't. I don't remember when I even solved this, but I have solved this before because it is recognizable. But I don't remember all the details because that's not the point of I my approach is to get to a point where I don't have to remember particular solutions, right? I just have to remember how to do it or the techniques and like first principle, like like if you have a I guess I've been saying like a lot, but if you have like if you have a physics problem, you're not going like I like to start from like doing calculus and stuff like that, where you get the formulas like for kinematics or something like that from first principles, and instead of like just memorizing all these formulas from physics. And I don't know if y'all, I don't know if people have this experience where way back in the day, maybe, in high school, they taught physics in a way such that it's like all these formulas, and you just struggle to kind of remember the formula and how to apply it and so forth. And then you take it in college with the one, with calculus, if you get that far. And with calculus, it's just, oh yeah, it's just this formula, and then you integrate it, and then you take the derivative. And stuff like this is how you get all the formulas and stuff like that, right? Like for me, like the distance formulas are just like integrals of the velocity is the integral of the acceleration, right? No, the other way around. Sorry. Oh no, yeah. Velocity is equal to integral of acceleration, and you integrate that again, and then you get the displacement, right? I know plus or minus c or something like that, right? Or plus c, I guess, where c could be negative. But you get the idea, right? The idea is that building yourself strong enough so that you don't have to memorize the answer. So that's a long-winded way of saying I don't remember how to solve this, but that's okay because I know I can resolve it. So yeah, so I do remember there is an invariant, and I don't know that there's an invariant, but actually one thing that is cool is that I actually recently picked up a tablet. I don't know if you could see this. A tablet. I'm gonna try to use this to kind of draw it for an explanation. Hang on. Let me set this up. I don't know if this is gonna be good, so definitely leave me some feedback in the comments below. And then yeah. Okay, we'll see if this actually works okay. But okay, so now let's say we have something like this, right? Okay, let's see if this works. Still playing around the setup, so this may be a little bit weird anyway. But yeah, okay. So then the idea is that, okay, let's say you go from, the way that I like to think about these problems is that, let's say we are at, we're going from left to right, we have, say we look at this, and then how do we look at the past in a good way, right? And in other words, we're trying to figure out how to do an invariant. And then the first thing I would think about is that, let's see, right? So what does this mean for 6, right? So the largest rectangle is going to be the previous height times, like the previous max height times some distance width, right? So then you can also go this, but of course, if you're limited by here, then everything to the left of this is going to be at most this height. So then now you end up with this kind of shape, right, where it is going to have where you try to figure out what is the max 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 thing. How do you do that actually? That's interesting. Because then the idea here is that, wait, let me double check that this is on the screen. Okay, because that would be a little bit embarrassing, which has happened before. Where these have variable widths, so these widths don't really have to be directly next to each other. Like for example, this could be one, this could be say this could be another one, but this could be two, right? And of course, going forward that way, maybe like, you know, because the next one is a 2. Let's say we have this one which maps to this. Then in this case, going to the right of this will limit all this stuff. So already we have an idea about how to build this thing, but then the question is, how do you do this in how do you get the max of this in a good way, right? Let me also double check really quickly on the constraints. The constraints are 10 to the 5th for the h, so that means that we have to do things in a sub-quadratic way, right? Meaning that n squared is going to be too slow. Also, I should have checked that first, because if that's possible, then I'm drawing all this stuff for no reason, and that's a whoops. But okay, so I know how to maintain this thing, but how do I get the current max height, right? Because if we're at the 6, for example, we don't want, if we're at the 6, we're at this one, this 6 height, we don't want to have to check, you know, let's check the what we would do is we check the area of this, and then area of this, and then area of this, and so forth. So we definitely want to avoid that. How do I check that? Oh, and also this thing, I guess. I guess one way to think about it is, I guess another observation is needed here. And I think the observation that I need here is that there is an invariant about adding this last column, right? And what I mean by that is that what I mean by that is that is that true? Wow, man, I don't really have like, what I was going to say is that you add a new column, and let me actually change the colors a little bit so that's a little bit less confusing. Oops. Okay, fine. So let's say we have these. Okay, let's say this is 3 because I didn't close the box. This is slightly harder to use. Oops. Okay, fine. Well, in this case, this is always going to be bigger than something of a shorter height. But you know, if we want to match these 3, right? But then I guess at a certain point, but this could be bigger than, you know, even in this weird thing. Maybe I don't remember how to solve this, so you know, bear with me. And maybe this is a good time for a disclaimer that I usually solve these live, so if it's a little bit slow for you and you're not happy with it, fast forward, watch it on 2x, skip ahead, maybe watch another video, it's fine. But you could kind of see my thought process if you like. So that's what that's why I like to do it this way, even though if maybe it's not quite direct to the solution, say. But yeah, let's say all these boxes have height and width of 1. You can see that the 9 boxes is bigger. The 9 green boxes and kind of 8 yellow boxes. I mean the yellow because it's overlap with the green, but hopefully you could kind of extend that downwards and see. I mean, I could use another color, I suppose. So then the question is, how do you decide when to use the bigger one, right? And then also in the future, you know, let's say in the future you add a shorter box, then then this thing doesn't apply anymore, right? Like you would go, I feel like I'm missing one observation. I was gonna say something about greedy, about just always add 4 to the thing, and then 3 is whatever. But okay, I think I have an idea. I think the reason why I'm struggling a little bit is that I try to resolve everything. Okay, yeah, because I think the problem with what I was trying to do here is that at this particular instance, let me use another color real quick. At this particular instance, I'm trying to resolve everything with this column to the left, but that's not really necessary, right? We could actually delay that a little bit. And what I mean by this is that we can resolve everything to the left here, but we don't have to resolve everything to the left of this. And what I mean by that is that when we get to the very end, let's say we look right here, right at this box. I'm playing around the drawing a little bit, sorry friends, it is kind of fun. But yeah, let's say we have this box, then we know that we no longer need the top of this chunk, and then now we can process this green box because we know that this green box extends all the way here, right? And we can draw different heights and stuff like that. Let me redraw it in a maybe better way. I think I drew too much here on top of each other because I'm still trying to figure out the best way to use this thing, because this is my first go, right? Okay, let me actually take the one from the examples real quick again, but put it here. Okay, so here we got the invariant enough to build something of a stack to kind of look backwards that way. But then my idea is that, okay, let's say let's start by having a 2, right? The 2 is obviously we just put it on the stack, and then here at 1 we know that the height of this height of 2 no longer matters, right? So oops. So then now we have something like this, right? And then now we go to the 5. We want to use all of 5, and then we also we don't have to process the 1 yet because we know that the 1 the one rectangle goes to the right, but we know that it can continue to go to the right, right? Here's 6. We drew this, and here again we don't have to actually, because I think I was trying to process on push, if you will, but we can actually process on pop, right? And what I mean by this is that the 6 will draw another rectangle. In a invariant kind of way, we know that the 1 extends to the right and the 5 extends to the right. And then now we look at the 2. What happens to the 2, right? Well, here at the 2, and I'm going to let me actually change to color real quick. Here at the 2, here let me draw the straight lines a little bit straighter. Yeah, so let's say we have the 2, right? Then what does it mean? Well, now we want to extend it to the left this way, and we know that the 6 and the 5 is no good. I mean, we can process. Now we know how far 6 could go because we have the width of the left side, and we know that the right, the left side is just the boundary between the 6 and the 5. And then the right side of the 6 is obviously our current boundary because it cannot go right any longer. So then now at the 2, we now process the 6 and the 5, and we have this, and then we see the 1. So then we know that the 1 keeps on extending to the right, right? And then the 2 goes extend all the way here. And then now here we have the 3, and again, you just wait. And then at the very end, we could process the 3, because we know that the 3 ends at, well, the very end. And yeah, and then the 2, we also process the 2 because we know that it ends here. And then lastly, we could process the 1 there. And then of course, when you process these numbers at the end, you just choose the max of all these things, because that means that for this height, almost in a way, you're trying to go as left as you can and as right as you can. And as left as you can, it's just the min, right? And of course, this is the visualization. You can definitely figure out how to work that into, what I know there's some fancy names around like monostack and stuff like that, but these are what I would like to think about these what's it called, monotonic data structures, if you will. I like to think about them not necessarily as a thing that you have to know or memorize, but it's just if you know stack well enough, if you know queues well enough, then these are just emergent properties, right? You're not explicitly knowing that they're monotonic. It's just that you built on it, and it turns out that they're monotonic. So I think that's the thing that I would say. Okay, I think now it's time to turn this thing off. My drawing thing. And now let's get to programming. Hopefully that was a good explanation, though it took me a little while to get there because, well, look, like I said, I don't remember to do this by itself, or I don't remember to do this just to whatever. I'm doing this from scratch, or maybe not from scratch because I've been doing this for a long time, but I don't memorize the solutions for these things. So anyway, okay. So now let's say let's have a stack, and then now we have for I h in enumerate heights, right? So that just gives us the I index and the h index, and then now let's see how far can we go left before we see a smaller or a shorter I guess it's a bar. I was gonna say rectangle, but right. And this is basically what we said, which is while length of stack is greater than 0 and stack of -1, which means the last element. We do want to store also the index. So actually this is a good opportunity to use the what's it called, the walrus thing, because I don't use walrus enough. But yeah, let's just say left index and left height. I actually don't know what's this, because now it's a little bit, I don't know if this is correct actually, but and left height is shorter than h. If it's equal, then we don't pop it because we what do we do if it's equal? I guess it really doesn't matter. We just don't pop it, right? Because if we don't pop it, we'll just process it again, but then it'll be overlap. Where if we do pop it, then we might miss a condition. I don't want to add an extra condition. So let's pretend this is good syntax, because I'm actually not quite sure about how walrus because it's a relatively new for me anyway operation. So yeah. So while this is the case, we just pop. Yeah. But before we pop, we want to process that as a thing, right? So let's say we have the best width or best area. So best is equal to the max of the best because we're trying to get the largest. And then here, the width is just equal to I minus left index, is it? Plus 1, right? Because it includes the current thing. And then this times the... Oh, actually, I'm wrong here. Sorry. This should be greater than, because we keep on popping stuff that's greater than, right? Because like we drew before, if it's greater than, then you kind of cut into it, right? So yeah. So this is that times the left height. Okay. So I think that's the general idea. Yeah. I'm going to click on one code real quick just for a syntax check, because I know that this should not be an infinite loop. So yeah, so I invalid syntax. Oh, yeah, I did forget a parens. Thanks. Okay, I mean, we expect this wrong answer, but I just want to know that this syntax is correct. This looks a little bit yucky because generally you do this and it returns the left assignment, so then you could directly compare. But I guess that's a true assignment, which is, I don't know if that's quite the right syntax or like the optimal syntax. I mean, it's good enough, but anyway, so we're all learning here. Okay, so then now at the very end we can push or append, in this case we push to the stack the current I and height, and that's pretty much it. And then of course at the very end we do this thing, and let's just say, right is equal to length of heights. I might be off by 1 here. I think this should be okay though. Maybe. We'll be a little bit careful. So we'll do the same thing here. I think this is correct, except for that's not. So we don't add a +1 here because it's just a boundary. I could be wrong. So let's play around that. Oh, this is wrong though. This should be -1. So before I do this, let me run it again just to make sure this doesn't mix. Basically, let's just get the max left gets the So okay, so as you can see, I messed up on the syntax and it's coming back a little bit. Maybe I don't know the walrus syntax then. Left index not defined. Did I mistypoed it? Did I mess up the walrus operator? Maybe I did. I am very new to the walrus operator, to be honest. So give me a second. Yeah, I guess so. But I maybe the walrus for tuples doesn't really work. Maybe. Oh no. Let's see. Let me Google. Hang on. Python walrus operator tuple. Walrus operator does not allow unpacking assignments. Okay. I mean, I wasn't sure that I can do this, to be honest. So this is fine. We'll just have to rewrite it a little bit. So while stack, I mean, this is fine, right? Else we break. That's pretty much it. Not a big deal. Yeah. Let me run it real quick just to make sure I have the syntax correct this time. Okay, good. We can even return best. It's just that we won't. In this case, I think we get the right answer because the 2 and the 3 doesn't matter. Maybe not. Okay, maybe I'm also still off by 1 though. So we should check that because okay, I was a little. Maybe I don't need this. Is that true? Okay, I mean, but yeah, but we still have to do we have to process the rest of the stack as we talked. So yeah. Oh, I guess we don't need a left height then. Here, I don't know that we're not off by 1. I might have to think about this a little bit. Okay, so this is good, and this is basically all the things that we talked about. Not super confident about this, only in the sense that I worry a little bit about off by 1. The idea is mostly right. It's fine. I'm just worried a little bit about off by 1s and why this is not. Why do I not have a +1 here? If the left index is, for example, for 5, let's say 5 is 0, 6 is 1. 1 minus 0 1 minus 0, right? So why should that not be? Oh, okay. No, I'm wrong on this. That's why. Because we processed this not at the 6. Again, I made the same mistake that I did when I was doing the drawing. I processed this not at the 6. Well, no. So I think I had the wrong mental visualization. So yeah, this only applies not between the 5 and the 6. This applies between the 6 and the 2. I keep on messing myself up. And when you process the 6 and the 2 will mean that 2 will mean that you're processing the 6 and the 5 together, and yeah, and of course in that case, the 5 has a width of 2, and of course the index will be 2 apart. Okay, I think now I'm convinced and happy about that. Might have some silly errors anyway, but still. Okay, let's try. Let's see what happens if we have like. I'm just plugging in random numbers. I think the one that I did want to try was, what if you have a 0, especially at the end or something. Say, I think it should be okay, but I don't think that I handled it a little bit differently. Okay, but I am wrong though. So, so 120 shrinks it to. So 120, we get 125 is the answer, then that's good. But then when we have a 0, why does the 0 not process to 120? Left height is greater than 0, right? That's weird. I mean, I'm glad I caught this, but yeah, let me, and just for visualization, I could try the same number but without a 0 in the end. And this is just a little bit lucky in that I didn't really intend this to be the case. Okay, so I am consistent about it. So that means there's something wrong here as well. Huh? That's weird, actually. I mean, I get the 125 answer, so then what? 3, 125, 4, 120, okay. Right before we pop, 5 minus 4. Okay, I see. This calculation is wrong because it is calculating. This is calculating where it begins, but not, sorry, where we. So this I is wrong because we want basically. We want to. We're not tracking the left item. We're tracking almost the right side of the left item, right? So this is always going to be mostly 1 or something, or maybe not, but it's way wrong, is what I'm saying, because there is a properly where we're just not tracking the right thing. What we want is actually, what do we want? So that when we pop, we keep track of the leftmost thing. So let's do that. Leftmost is equal to 0. I don't know if this should be 0 or -1, but every time we pop, we do leftmost is equal to. Oh wait, leftmost should not be. It should be I. Whoops. And then now we want to move it to the left, which means I guess technically it's a min, but actually we do it here, and I think that should be better. Yeah, maybe. I mean, I know that I didn't fix it for here. Do I need to fix it for here? No, because once I put it in correctly, I don't need to fix it there. Okay, so as you can see, I will still make mistakes, so that's a good thing. I mean, in that, it's a good visualization on how I debug and try to visualize it and kind of suss out what you think is the most suspicious. And for me, just working through an input, you can see that I go, okay, where do I get 125 from? Where do I, and how come I didn't get 120 times 2? And then I realized that I was getting 120 times 1. That allowed me to kind of look at why this is wrong. And then I realized that the left index didn't actually contain what the left index is. It just contained the index when you insert that bar and not extending it to the left like we visualize in the drawings, right? So that is basically, yeah, okay. Let's say now I'm confident, or I wouldn't say confident, but more confident. Let's give it a submit. And hopefully I didn't miss any silly case. Okay, cool. Much slower than a year ago, but I feel like they've been just adding a lot of test cases. So I don't know. Maybe I'm wrong though. 669 streak. And yeah, oh, I didn't go over the complexity, but as you can see, this is just a for loop. And you could see that there's a for loop and a while loop. The way that, this is not n square, and the reason why that is because for every item in the stack, it corresponds to one item in the input. And of course, each item can only be pushed and popped once, because so that each item can only be pushed or popped once, so only 2 operations at most, or whatever you want to say, not operation, but so therefore this is going to be linear time in total. In terms of space, same thing, we push only the items on the stack once at most, so that's going to be linear space. So linear time, linear space, and that's pretty much all I have for this one. Let me know what you think. I mean, I think this is just a area formula. How about I didn't have to explain it, though I didn't. So yeah. All right, well, weekend is here. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.